Saxon Algebra 2, Lesson 4. Ready for some midnight math? Here we go. This is a very manageable lesson. There are 7 example problems, but there's nothing dramatic in here. The first thing we're going to talk about in part A is the distributive property. I'm going to sneeze. I can pretty much tell you that right now. Distributive property, it's useful. We've done it a million times. The basic idea is that we're multiplying something on the outside plus 2 terms on the inside, and we just have to remember to multiply both, and so it equals. We can write it in shorthand like that. But John would never give us anything so simple and cute. He gives us big gnarly beasts like this. 4a squared b Okay, I copied this just the way John wrote it in the book. And what we're going to do is we're going to distribute. We're going to do the distributive property, right? Which is multiplying this outside one times the first one and then the second one. Because we've got fractions, then we do the same with the fractions. This is supposed to be an exponent. That doesn't look like an exponent. It's a to the 4th. Okay, so we multiply, we distribute across the top, we distribute across the bottom. We've got these negative exponents, and if you wanted to, it wouldn't be wrong if you said, hey, you know what, I'm going to clean up all those negative exponents first, but you can leave it, it's fine. And then we'll see what we can clean up at the end. Remember that we are using our rules for exponents just like we did. The main one we'll use here is the product rule because we're multiplying. In some cases we'll have some matching bases, but let's just go ahead and start multiplying. 4a squared times b to the minus 2, there's nothing we can combine in that, so it just becomes 4a squared b to the minus 2. Then we'll do minus because that's the minus sign. Over, let's see, 4 times 3 is 12. Then we'll do the a's. There are now 3 of them. And then 1b. Okay? So there's our numerator. Oh, sorry, I was just looking at the solution. Now we'll do our bottom. A to the 4th b. And then b times this one, a squared b. All right, that looks pretty good. We used our product rule, but we notice, okay, we've got some bases top to bottom still, right? So we can use the quotient rule, and let me just write these down. The product rule is that when we're multiplying matching bases, we add the exponents. That's kind of squeezed in over there. Hope you can see it. If we're dividing, we subtract the numerator exponent minus the denominator exponent. So this is the one we need to use now, and we're going to try doing it in our heads, and we'll see if your brains implode or not. It'll be fine, I'm sure. All right, so the first term is going to be 4. This is how I like to write it. We have a squared over a to the 4th. The way my brain sees that is like this. I'm not going to do the b's for now. I'll add those later. There's a to the 4th on the bottom. There's a squared on the top. My brain splits that a to the 4th into 2 packages like that, and then one set of them gets canceled, and then this remains. Okay? Does that make any sense? I hope that makes sense for you. When I see the b, my brain says this. we're already multiplying by this b, right? This one gets sent downstairs to be another b squared. And then these I can add together to be b to the third power. So I have this on the bottom, this on the bottom. That's the way my brain simplifies this. I go 4a squared on the bottom, and then b to the third on the bottom. Okay, that looks kind of weird, but it's okay. Minus, okay, then we'll do the same thing here. 12 stays up top. 3 minus 2, that leaves me an a there. And then the b's go away altogether, don't they? So this is our final answer. All right. I'm using these rules, but I'm carrying most of the information in my head, and I'm visually pulling things apart to cancel too. So do that however it works well for you. Example 4.2. Ready? Here comes another one. Okay, double checking just to make sure I'm right. Copied it right. Again, I see that I've got some negative exponents in here. It wouldn't be wrong if you wanted to clean those up, but we're just gonna forge ahead. We're comfortable working with those minus exponents, so we just leave them in place. I am gonna cross this off because any base raised to the 0 power always equals 1. And I don't need to multiply by 1. So I can cross that off and ignore it altogether. Now I'm ready to distribute top to top, bottom to bottom. And remember that when we're multiplying, we add the exponents. I know I've already written this out today, but I'm doing it again because it's hidden. Okay, so that means I've got a to the minus 3 and a to the 2. That gives me a to the minus 1, bc over c to the third. Minus, let's do the top again. This will be 3a to the minus 5, right? I add them over c b to the minus 2. I didn't put that in alphabetical order. I'll catch it on my next pass. Remember, this we can see as to the 1, so that when we're adding those, that's where I got the 3. Okay? Now let's simplify. This is going to go down because I'm not going to say anything. That's just how I use this rule. And so this becomes a to the minus 1, b over c squared, minus, and it looks like there's nothing I can do for that one, 3a to the minus 5 over b to the minus 2c. I want those alphabetical. Now, when I take this to the solutions manual and check my answer, I may find, who knows what John did, right? He could have switched these to positive exponents. You know, he could have rewritten it all with positive exponents. He could have rewritten everything with negative exponents. He could have put all of the variables in the denominator. He could have put them all in the numerator. He could do all kinds of crazy things that are not more right or wrong than anything else. So I may have to work to see if my answer matches to his. But when I look in the book, it just so happens that we have the same approach. All right? All right, moving on. We're gonna start solving some basic equations. You've done this before many times. We'll just get to work on it. The rules of algebra. And I think we're just gonna cover the first two today, yes. I'll remind you of all three of them, but these problems are gonna focus on the first one. The first one is that we can add or subtract any number to both sides of an equation. It's okay to do that, right? Because if we add or subtract the same number, I should say same. That's probably better. As long as we're doing the same number and the same operation to both sides of the equation, it's not changing. It's exactly the same. The second rule is that we can multiply or divide the same number, but it can't be zero. So we say non-zero number. And it has to be to each term on both sides of an equation, and it'll stay in balance. We have to say non-zero because you and I both know that if we divide by 0, we're going to blow up the universe, and we can't have that. Dividing by 0 is no bueno, and if you haven't done this before, or if you'd like to do it again, go watch what happens when you try to divide by 0 by Googling kingdom implosion. I don't remember exactly when this happened, but I'm pretty sure you're not old enough to remember. But the kingdom was what we had before CenturyLink and T-Mobile Park or whatever the heck it's called now. And they blew up the old stadium, and that's what happens when you try to divide by 0, so don't ever do it. The third rule, these two are for equations. And this one is for expressions, which means not equations, which is that you can multiply any number top and bottom. Let's do this it's numerator and denominator, top and bottom of an expression. That won't change it either, okay? Those are the three major rules of algebra. Like everything related to math, putting it in words is awkward and clumsy. Seeing it in operation is easy. So let's practice solving some equations and see the rules in operation and go, oh, yeah, that's right. That's not hard at all. And we have a handful more problems, but we're mostly done. 4.3. Whoops. There's a minus sign there. 12 minus the quantity. Okay. There's our first equation to solve for the year. The first thing that we always want to do is take a look at those parentheses and see if we can eliminate them. All right, I want to start with this one because it's easier. It's preceded by a plus sign and there's no number there. What that means is we can just take those off. Those are fine. We can just get rid of them. It'll be minus 2 plus x minus 3. If there's a plus sign with no number, we're good to go. This one has a minus sign. So we have to essentially distribute the minus sign And you can imagine, if you want, a little -1 squeezed in there that we're going to multiply each of these by. But what it's going to essentially do is turn both of those terms negative. All right, so a minus outside of parentheses needs attention. A plus sign outside of parentheses can just poof, disappear. All right, well, we got rid of the parentheses, so that looks really good. Our second step is to add like terms. Adding like terms means that we focus only on one side of the equation at a time. So I look at this side of the equation and I go, okay, there's a plain number, there's a plain number. We can combine those. So I'm going to say 7 minus 2x, right? 12 minus 5 is 7. Now we clean up the other side of the equation. Oh, look, there's two plain numbers. So I'm going to say x minus 5. We're just sorting things and organizing them. Looks nice, right? Now, for those of you who haven't heard my story about my teacher, Mr. Leckrone, who was my algebra teacher in 7th grade, he told about solving this part of the equation by likening it to swimming in the ocean and observing schools of fish swimming around together. And when the fish are happy and at ease, they mingle, right? The different schools of fish will mingle together. You've all seen Finding Nemo, you know this. They mix together, but at the first sign of trouble, they will separate and go team up with their species and form those protective balls, right? So that's what we're doing here, is we're swimming the fish so that they can be with the rest of their species. In this particular example, we have X fish and we have plain number fish. So we want to swim all the plain number fish to one side and we want to swim the X fish to the other side. It doesn't really matter which fish go in which direction as long as they end up with their friends. But often we can kind of strategize around this so that we end up with a positive number. For example, I see, okay, in order to solve this one, I'm going to add 2x here and I'm going to add 2x here. This will cancel and then this will give me a nice positive value for 3x. I like that. So I'm swimming my X fish to this side, which means I better swim my plain number fish this way. So I'm going to add 5 and add 5. Those cancel. There's my equal sign, and this becomes 12. Okay? So this this third step, I call it swimming the fish. And I wish I had a picture of Mr. Leckrone to show you because he was a 70s gem. Mustard colored shirt, olive and mustard tie, handlebar mustache. You just wish you had Mr. Leckrone for a teacher. But he was really cool and I liked him. Okay, so we swam our fish so that we've got plain numbers on one side and variables on the other side. And then the last step is to divide. Here's our x. We always pay attention to our x and say, what do we need to do to get our x by himself? We're going to have to divide by 3. He's being multiplied by 3, so we use that inverse operation business. The opposite of multiplying is dividing, so we divide both sides by 3. That cancels. That simplifies. X equals 4. I flipped the sides, right? That's okay. We can do that. I think it looks better to say x equals 4 rather than to say 4 equals x. It's just me. All right? Cool. Now, let's do it again with harder numbers. I know. I'm such a glutton for punishment or something like that. Look what I've done to us. Well, I didn't do it. John did it. He gave us fractions. Okay, so I see a couple different things going on here. I see fractions. I see confusing subtraction signs. I see some whole numbers that are floating. I don't like floating numbers. You're either up or down. There's no floating in between. So that means that everybody has to join the fraction club. Letters and numbers alike. I don't want anyone floating. So I'm going to do that right away. Now we're going to follow our steps again, even though it's fractions, and we're going to see what we can do to clean this up. I'm going to have to distribute, aren't I? And here's a minus. You can think of it as a -1. Sometimes that's helpful. We're going to distribute that as well. So let's start multiplying. All right, 3/5 times, or 3/1 times 5/6. I see I can cancel there. So that's going to become, because it'd be 15/6. It's going to be 5/2, right? Because that cancels to 2. Minus, and this would be 5x/1, right? Because the 3's are going to cancel. All right, equals, this becomes +1/2 minus x/1. Make sense? Okay, I may or may not want those ones like that. For now, I'm just going to leave them. And let's see what happens from here. I would like to add, I want to swim these fish, right? So I'm going to add the 5x's to go that way, and I'm going to subtract the 1/2 going this way. Make sense? Those cancel, and I get 4/2 equals 4x. That's kind of interesting, isn't it? This reduces to 2. 4/2 is the same as 2. So now when I divide by 4, it's not so gross. That cancels. X equals 1/2, which is the reduced form of 2/4. Yay! All right, this was a great example because even though we started with these disgusting numbers, they quickly sorted themselves out, and even though our answer is a fraction, it was quite lovely. Okay. Here in the last section are 3 quick examples of a little mental process you can do to help scoot your algebra along sometimes. It's called the change sides, change signs concept. I don't like the name of that. I think it's hard to say, but we do this. We all get this and understand this all the time. If we have something like this, x minus 2 equals 7, we quickly see that when we swim the fish, this is going to turn into a plus, and it's going to be x equals 9. Because when we change sides, we'll change the signs. This -2 will become a +2, and we add it quickly. That's a little mental shortcut you can take in order to scoot this along quickly. Okay, let's look at another example. There's 2 more examples of this. I think most students stumble onto this fairly quickly. And so we don't have to worry too much about this. All right, we're supposed to solve for p. It says use transposition. That's a fancy name for this. Let me just write that down. Transposition. Trans means to move position, right? So when we change sides, we're transpositioning the numbers. We're supposed to solve for p. Use transposition to solve for p. Okay, p equals, and then it's going to be +3x, right? Because when we change sides, it will change signs. And then it will become -4. This one stays the same, so it's +7y. Final answer. Final answer. All right, and one more. Solve for y. Okay, we're supposed to solve for y. John told us that. We wouldn't otherwise know. All right, so we can quickly go 3y equals 2x minus 5, right? Because these guys change sides. And so they change signs, and then we divide by 3. And we could leave the answer written like that, or in the future, we're going to find more value in writing the answer like this. 2/3 x minus 5 over 3 with the equal sign there. I'll explain when we get there why this format is sometimes preferable, but this would have been a perfectly fine answer for me too. But if you had this and then you looked in the solutions manual and saw John, you would just go, yay me. Okay, so transposition is this logical process of just knowing that if you're changing the sides, it's going to change the signs, and you don't have to show the step-by-step every time. Okay, that is the end of lesson 4. Go ahead and do, I'd like you to do all the practice. There are only 2. So in general, unless I tell you differently, I want you to do all the practice problems and then the odd of the problem set. My goal is for you to complete your homework within an hour. We're still fairly early in the game. I expect that within another couple weeks, the time that you take will come down a little bit. But if you're ever taking more than an hour to do your homework, I want you to message me and tell me, all right? More than an hour. The other thing I want to remind you is that on Friday, we're going to do our first check-in. That means you call me on FaceTime between noon and 3 p.m. If you are booked solid during that time, get a hold of me earlier and we'll come up with an alternative. I'm probably going to need about 15 minutes of your time. I'm going to ask you how it's going. I'm going to ask you what you think of my ring light, and I'm going to give you a problem to work right there. I'll have you turn down your volume and work the problem, and then when you're done, you'll show me what you did, and we'll correct it and move on from there. All right, lesson 4 is in the books. Thank you. I will see you on Friday.